Hello, ladies and gentlemen of geometry. This is Mr. Heeren, and today we are going to talk about 6.5, talking about angle of elevation and depression, kind of what that means. So elevation, just like how it sounds, means you're looking up, and depression means you are looking down. So that's kind of where we're starting with. So the angle of elevation of an object is seen by an observer is the angle between the horizontal and the line from the object to the observer's eye, so the line of sight. So what does that mean, not in a whole bunch of words? So all that means is this. So that means if you are on the ground and you see something in the air, you see, a bird in the air, so from your eye line up to that bird, that's going to be your angle of elevation right there. So that is your angle of elevation. So what it does is it creates a right triangle right there. So we can use trig, we can use SOHCAHTOA to help us solve. So, but this right here is your angle of elevation. So that's kind of what that represents. So now, angle of depression. Angle of depression means something different. So if I'm standing on the roof of a building and I look down and see a tree, I'm looking down at the tree because it's purple and there's not very many purple trees running around. That is looking from straight ahead and down to the tree. So that creates a right triangle. Okay, that is my angle of depression right there. So now what kids love to screw up is that they believe that this would be my angle of depression right there. That is going to be wrong. That is not the angle of depression that we want. This one right here, this is going to be your correct one. That is your angle of depression. If you think about it, you start by looking straight out ahead of you, and then you angle your head down to look at something. That is the angle of depression. So now if we look, a tree casts a shadow 25 feet long. So here's our tree, here's our shadow. Okay, so we have our tree, we have our shadow. The shadow is 25 feet long. The angle of elevation from the tip of the shadow to the top of the tree is 64 degrees. So 64 degrees in there, figure out the height of the tree. Now, it shouldn't take us very long to look at this and figure out which trig function do I want to use. I've got opposite, I've got adjacent. So opposite and adjacent. So that should tell me I want to use tangent. Tangent is opposite over adjacent. So I want the tangent of 64, and that's going to be equal to h over 25. Now, from 6.4 and part 1 and 2, if you remember, I showed most of you this shortcut. All that happens is, sorry, I don't want to do that. Back up. All I want to do to solve this is multiply both sides by 25. So tangent of 64 times 25 should be 51.257, and that's going to equal h. So it's going to be about 51.25 feet. That will be my answer, or 26 feet if you really want to be picky. But that's how tall my tree is going to be. 64 degrees was my angle of elevation. So now, a jet takes off and rises at an angle of 19 degrees with the ground until it hits an elevation of 28,000 feet. How much ground distance is covered in miles? So, let's take a look. So, we hit an elevation of 28,000 feet. So the jet takes off and keeps going until it hits 28,000 feet. It starts off with an angle of 19 degrees. We want to figure out our ground distance. So again, no hypotenuse. I don't care about hypotenuse. I've got a right triangle, so I would like to use tangent here. So the tangent of 19 degrees is going to be 28,000 over my ground distance. So now remember from 6.4, from the SOHCAHTOA stuff, I showed most of you this, otherwise it was in the video. All that really happens here is these two switch places. $28,000 over the tangent of 19. So that's going to give me 81,317.9. Now, this is in feet. So it's going to take 81,000 feet to get 28,000 feet in the air. They want to know, what is it in miles? So all I do is take 81,317.9 and divide it by 5,280. Why? Because that is how many feet are in a mile. So I'm just going to take my answer, divide it by 5280, and I'm going to get an answer of 15.40. So it takes a little over 15 miles to get 28,000 feet in the air. All right, so 95% of this is going to be in your setup. Make sure that that's okay, and then you can go from there. So here, from the top of a vertical cliff, 40 meters high, so this thing is 40 meters high, the angle of depression of an object that's level with the base of the cliff is 34 degrees. How far is the object from the base of the cliff? So 34 degrees right here. That is my angle of depression. Pardon me. This is going to be my angle of depression. So if that is 34, so is that. Okay, these two are parallel. 34 and 34 would be considered alternate interior lines or angles, so therefore they're both 34. So this is 34, this is 34, this is an angle of elevation. Do not tell me that this is not 34 degrees. Do not tell me that it is. That is not your angle of depression. Okay? That is not your angle of depression. I don't know how many times I can emphasize that. Don't do that. So here, I want to know this, my ground distance. Put D there instead of H. So the tangent of 34 equals 40 over my ground distance. So again, these two switch places. A little calculator grunt work gets me that that is going to be 59.30 meters. That is how far it's going to be. So tangent of 34 equals 40 over D. Little algebra moves that thing around, and we go. All right, let's take a look here. Pilot sights the beginning of runway and must approach it at a 5-degree angle of depression. The plane is 182 kilometers from the beginning of the runway. What is the plane's altitude round to the nearest kilometer? All right, so this plane is 182 meters from the beginning of the runway. It's got a 5-degree angle of depression. Make sure that that's 5 degrees. If you wanted to, and I mean you can completely do this if you wish, this has got to be 90 degrees. So if this angle is 5, my angle of depression is 5, then that angle underneath has got to be 85. So there's my 5, there's my 85. So that's 182. What is my height? How high is that plane in the air in kilometers? So I can use either one. I'll just use 5 because, stay with consistency. So the tangent of 5 equals my height over 182. So that's going to be the tangent of 5 times 182. So that's going to be 15.92, but it's set around to the nearest one. So that plane is still going to be 16 kilometers in the air. Okay, last kind of problem here we're looking at. Surveyor's 100 meters from a bridge. The angle of elevation to the top of the bridge is 35 degrees. The surveyor's instrument is 1.45 meters above the ground. Find the height of the bridge to the nearest tenth. So he's got this survey equipment. All right, it is 100 meters to the bridge. Okay, this is 1.45 meters off the ground, and the angle of elevation to the top of the bridge is 35 degrees. So that is 100, that is 35. Figure out the height. So when I figure out this height, all I got to do is add 1.45 meters to it. So once again, I'll use tangent. Tangent is a very popular one to use right now. So my height is going to be the tangent of 35 times 100, which gives me 70.02 plus the 1.45. So that's going to be 71.5 meters. That is how high the bridge is going to be. Okay, last one. Search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. The angle of depression is 42 degrees. They tell us that. The helicopter is 18 feet above water. What is the horizontal distance to the swimmer? So this one you guys should be able to set up. So we're just going to go tangent of 42 equals 18 over x. These two switch places. So it's going to be 20. You know, it's 19.99. I'm calling it 20 feet. Besides, it says to the nearest foot. Okay, if you have any questions, please come talk to me. Otherwise, good luck. Please make sure and double check that your setups are correct.